Hi, it's Chip, and during these sessions we're going to do something different. Instead of looking at the code of the repository of the game itself, we'll be looking at some code that one of the AI developers wrote, Relentor, and we're going to look at what type of performance gains we can get from his code. Because the AI itself is quite hefty, where we as humans can just analyze the screen ourselves. The AI has to check everything and do all kinds of routine checks that you wouldn't really expect an AI to do in the background. But because of that, the AI can be quite heavy on simulation. And sometimes you can't get around that, but sometimes you can. And I hope during this session that we'll find a scenario where we can get around that performance hit. With that said, let's look at what we have been given. So Relentor wrote this last month to me, and there are 4 functions. One is called true platoon RNG. That is platoon that is not false but true, and it's part of the RNG mod. It's apparently a very extensive platoon. For those that are unaware, a platoon means a group of units, like this group right here, I suspect to be a platoon. And they have a shared goal. And that goal, that behavior is described by a platoon function, and this is a platoon function. Then we have this reclaim thread that helps the AI deal with reclaim in the area, I think in terms of trees or the rocks. We've got the tactical threat analysis, which is what we'll be looking at during the session. And then we've got the AI build adjacency priority. And the idea of this function is that it helps the AI with understanding how to make use of adjacency. Right, so it's no longer just putting structures semi-randomly into the base like the Saurian AI is, but it's actively looking for a location, like right here, that is shared, that ensures that the adjacency of the power generator is given to the last vector in this case. For ourselves, we'll be looking at the tactical threat analysis, and the reason is quite simple. It is the easiest of the bunch that I know triggers every now and then, which ensures that what we're doing is still correct. Because we gotta check the code, we gotta make sure that the behavior between quotation marks is still the same, and that we don't introduce any warnings or errors because of a typo, etc. Now, you can already see that there's already some debug information being printed. Some of it is of Relentor himself. In this case, this is something that I added. And let's just look at the code and look at what is the code actually trying to do. So we know we have the right function. I added this log statement. We can see that right here. And then it does all sorts of stuff. And then we have the function again, because we have 2 AIs. And they both run this function occasionally to update their awareness of the map, to determine where is the danger, what should I be looking out for. So let's look at the function. First observation is that we are in the brain, and we're not... Yeah, I am recording, alright. Gonna make sure that I'm streaming too in case... Oh, Roey's there!
Hello.
In case someone joins in, gonna make sure that the stream is on too. So let's look at what's really going on in this function first. It's in the brain. The brain is pretty big, as a brain typically is. This is about 6,000 lines of code. I'm not a huge fan of such a large file. I'll come back to that in a minute. But let's look at the function in question. So initially we go over all the brains, we check if there is a hostile brain. Oh, no, this is the wrong. Where's my function? There it is. Alright. So the idea of this function is that we populate this table. That's what I understood when looking through the code. And then all the other AI functions use this table to direct their behavior. So we have some initializations. We have something called the IMAP size. So this is the AI grid. Let me show you what that looks like. Yeah. So we can turn on the grid, and then given a perspective we can see, for example, this one's a bit hard to see, but let's look at the commander here. There's a commander thread right there, and you can see now that once that updates, the commander thread should follow along. Not really doing that. Let's try something else. Structures not max. Again, hard to see. Let's go for overall. So this is all the thread information combined, and what we're doing here is visualizing the IMAP, which has a different size depending on the map. And the scan radius, I suspect, is that if you are at the center of the IMAP grid, then the scan radius would be the entire square of the IMAP grid. Then we look at enemy threat locations, which is populated by another function. I suspect that this determines locations to look at, like for example the base here, this base right there, maybe this platoon here. I already checked what the content of one of these values is, and it's roughly what we see here. We've got a two-dimensional position. It's not on water. We've got a threat value, so that will be one of these. And we've got the threat type. Here we can see structures not max, structures not max, right? So that would be these locations right here. And then for each threat, we check, are these structures, yes or no? Did we, what does this say? Game time minus threat insert time smaller than 25. I think this prevents us from checking too quickly, again, the same threat location, because in Supreme Commander the game is relatively slow in comparison to other games, so in 25 seconds the base is not going to be suddenly changed a lot, unless you got nuked. Then we find all the units, so this is the threat position right here. Right, this is the two-dimensional position. We look for all the units around the point. It's interesting that he uses this function, because we're dealing with squares. This function deals with circles, which means that there's these corner areas that I don't think will ever be, any unit in there would be hidden. But okay, this is something I added myself. I'll debug. And what this does is that if this coroutine runs, then we get a quick glimpse of what it is currently looking at. That's what all these numbers here are for. And then what we do is we go over all the units at the location. So if we, for example, have this location, then we would have all of these units here, give or take, right? All these units in this square. And then for each individual unit, we check whether or not it fits certain categories. And if it does, then we insert the unit along with some additional information. So let's just look at what we have. We've got the enemy index, we've got a value. This is the threat level times 2. We've got hit points. We've got the actual object, which is the unit. We've got whether or not it's shielded. Okay, that's interesting. This is in our utils. I think that would be RNG utilities. Which does another get units around point. Okay, so we're doing. That's pretty expensive. We check for every shield. We don't check if the shield is turned on. We just check if it's not dead. So if we would have a shield and then turn it off, then this power generator is still considered shielded according to the logic here. And we do some distance check to see if the target unit is in the radius of the shield size. Get shield radius above ground squared RNG. I'm not sure if this does what. I'm not sure if this is correct. But so another get units around point. This one's quite a bit bigger though. This one has a radius of 50. This seems a bit arbitrarily chosen. I think this is the radius of the or diameter of the. I think this is pretty big. This radius. I think this is way too big. But okay. So we check whether or not it's shielded. We keep track of the IMAP location. So this IMAP location would be a square, right? The center of the square, I suspect. And then we have some air and some land values that are set to 0. Are these set to something else? 0, 0, 0, 0, 0, 0, 0, 0. All right. And then we kind of do that again, right? For every unit that we have here. Which already shows a few issues from a performance perspective. So if we look at this, say that we do a query in this base. Let me go to observer mode. Is the other base more interesting? No, not particularly. Okay, say we do a query in this base right here. So what is going to happen is there are structures that are not a mass extractor here. Right, so this code triggers. Then we end up looping over all the units that are roughly in the center of the square, because we're not considering the units on the edge. And then for every unit that's in there, right, so all of these units, even these P-gens right there, these smaller ones, and yeah, and the factories, we do another get units around point, this time quite a bit larger. And even though the result is going to be, there's not going to be any shields here, right? We still have to go over all the units of the map of our army to determine that there are no units in this area that has this criteria. Right, so this is pretty expensive. We do that for every non-mass extractor unit in here, in this little square. And it used to be a lot more, right? As you can see here, the AI reclaims them at some point. Which is quite beneficial for performance too, but I suspect that's not why Rolento is doing it. And the reason that this is a bit inefficient is because one could argue that if this factory is looking around in a radius of 50, which is give or take this radius right here, I think, something like that. Yep, that was the scan, right? This is where it was scanning for the bases. Then it's gonna find the same units, the same potential shields that can cover this unit as for this energy storage, right? Because that's gonna be looking at, say, slightly shifted to the right in this radius. And then we've got this air factory, and that one's gonna have the same thing, but then slightly shifted again, right? Which means that we're doing the same query, this shield protecting target RNG, for each and every one of them. And that's very expensive, especially during the late game, where you can have a very large base or multiple very large bases, and then this really gets a bit hairy. So this is a good target for us to optimize. Because what could we do? Well, we could say that instead of doing a query for each individual unit in this square, we take into account the scan radius that we have, add that to the radius of the largest shield that we anticipate to have, and scan for that once for all the units in the square. So we would, if we would take into account this radius, that would be 22.5. We are playing a 10 by 10 map. Yeah, so that would be 22.5. So we would do one sweep of, say, 72.5 and keep track of those units, and then individually go over all our units here to determine if they're shielded or not. Whereas right now we're doing the opposite. For each unit we do a slightly smaller sweep, right? So we would do something like this, overdoing something like that to guarantee that we have all the shields. And by doing so, we're doing quite a lot of expensive operations. This one's pretty expensive, which we can improve, right? And there's more in this for loop that we can do, but we're gonna come back to that. Let's just look at all the other stuff that we have in this function, because we're not even halfway. So if we have any energy units, then for each energy unit, for each thread, we check if the this is, isn't this the same table? Yes. So we check, is this the thread that we originated from? Anti-air. Unit.air is thread.thread. Oh, okay, so we can have multiple threads at the same location. So similar to how we can have anti-air, right? This little fella here. And then we can have overall not assigned, structures not a max. So we can have multiple thread values at one location. And that's why all of these values here are 0, because we populate them afterwards. And we do that for all the energy units. So we're essentially we're checking, hey, for each energy unit, do we have this, which is an unprotected generator, or do we have this, which is a relatively safe generator? I suspect this would be used then for targets, target checking. Okay. This is interesting because we're going over all the threads again for each energy unit. We could easily have quite a bunch of energy units, 1, 2, 3, 4, 5, and we have 28 threads. So that means that for every energy unit that we have we go over a table of 27, 28 elements. That sounds a bit expensive to me. Let's see, do we have the Tech 1 pigeon still somewhere? No. Yeah, I just get rid of the Tech 1 pigeons. Okay. Then we have defensive units. So let's look at the categories. Defensive units, these would be Tech 2, Tech 3 defenses. Apparently Tech 1 point defenses are not considered a defensive unit. And we do the same thing. So for every defensive unit, for every threat, we set the air threat value, the land threat value, and we set land, depth, structure count, air. Oh, okay, so we try to determine how many. This is interesting approach. We try to determine how many land, so Tech 2, Tech 3 point defense, Tech 2, Tech 3 air defense we have at this location. But we're updating the threat value here and not the actual defensive units. We only update this. And if we count more than 5 of these defensive structures, then it's considered a firebase. Right? Makes sense, right? If you would have 6 PD here, then you could consider that a reasonable firebase. And then we introduce an enemy firebase table, which has roughly, a lot of information in there. We first create an empty table and then we create the actual table, but let's look at the information that we have in here. We've got a three-dimensional location this time. Another get threat at position land. Okay, so here we get the air and land threat separately, whereas here we use the cached version. So it's not different from what we already saw in terms of the structure that we have here. Got the enemy index, we've got the location, whether or not it's shielded, and the air and land threat values. Where is the naval threat? But I suppose that's for the next version of the AI. Then we check. This is still inside that if statement, but outside of the for loop. Then we check for every threat location. Aha, so here we populate these defensive structure values, and here they are used again. Then table entry is, and then we add that into the Firebase table. Okay. Aggregation table. Okay, so I need to quickly Google what this word means exactly, but I think I know. This means like combining, right? Yeah, clustering, okay. So what they're doing here is they're checking, okay, so if we have, say, 6 turrets here and 6 turrets there, then for the logic of the fact that they're in 2 different squares of the IMAP, they are different fire bases, but they're obviously from a non-AI perspective, if we would remove these lines, they are one and the same. And that's what this function here is doing. I think it is doing a check if it is closer than 60 units. This is a squared radius. So We take the square root of this, that's 60. I need to look into how often this happens. While not complete is true. Okay, and then here it checks whether or not they are all being validated. Interesting initial case. Then we've got strategic units. Let's look at their categories real quick. Intelligence. So this will be radars, stealth fields. Again, the air and land threat is attached to this to the unit in there that we have, the unit table, which would be something like this. We've got intel units. I'm at a bit of a loss. What's the difference? Let's see. Strategic is intelligence. Oh, whoops. No. Okay, so we've got strategic, which would be missile launchers. I suspect nuclear ones. And then we've got intelligence, which is radars. That was my mistake. And then we've got factory units, and we do the same thing there, and then we're completed. Okay. All right. So there's a lot of stuff happening in here, and the idea in the end is that we populate this table right here. So now we have a rough idea of what's going on in this function, and I think we can safely conclude that Relentor, in his assessment that he made, where he said this was function made to provide target data for things like Type 2, T3 bombers, gun ships, but I found it very hard to write in a performant way. And he's correct. I think that there are, by all means, this would always be more on the expensive side, regardless of what we do. But there are a few things, some low-hanging fruit that we can tackle. And I say we just get started with that after a short break.